Hi friends, I am Dr.R.Malini Devi, Associate Professor of Mathematics, PG and Research Department of Mathematics, the Standard Fireworks Rajaratnam College for Women, Sivakasi. Now we are discuss the topic matrices of linear transformation in linear algebra. The learning objective of this matrices of linear transformation is to find the matrices of linear transformation and the image of vectors under a transformation, to perform linear transformation using matrices, to identify the matrix associated to a linear transformation. Now we see a matrices of linear transformation. In linear algebra, linear transformation can be represented by matrices. If T is a linear transformation, mapping R power n to R power m, and X is a column vector with n matrices, n entries, then the transformation T of X is equal to A of X for some m cross n matrix A is called a transformation of matrices of T. Note that A has m rows and n columns, whereas the transformation T is of the form R power n to R power m. Next we see that matrix representation of linear transformation. Suppose we take two vectors V and W of two vector spaces over the same field F of dimension m and n. Let dimension of V is taken as m and dimension of W is equal to n. Fix an order basis V1, V2, etc. Vm for a vector space V and an order basis W1, W2, etc. Wn for a vector spaces W. If T is a linear transformation such that T is a function from V to W and it is defined as T of Vi equal to, can be represented as ai1 w1 plus ai2 w2 plus etc. ain wn, here where I varies from 1 to n. If I equal to 1, then T of V1 equal to a11 w1 plus a12 w2 a13 w3 plus etc. a1n wn. Here the coefficients are a11, a12, a13 and a1n will be the first column of a matrix under a linear transformation T. Again, if put I equal to 2 in that transformation, T of V2 can be written as a21 w1 plus a22 w2 plus a23 w3 plus etc. a2n wn. Here the coefficients are to a21, a22, a23 etc. a2n will be the second column of a matrix under a linear transformation T. Put I equal to m in that transformations, T of Vm can be written as am1 w1 plus am2 w2 plus etc. am3 w3 plus etc. amn wn. Here the coefficients are am1, am2, am3 plus etc. amn will be the nth column of the matrix. For under a transformation T, the first column we put that I equal to 1 in that transformation, we get the coefficients a11, a12, a13 etc. a1 and second one is a21, a22, a23 etc. a2n up to the nth column, nth variable am1 and am2, am3 and am. This is the matrices. This is under a linear transformation we get that matrices. Now see the problem. Example problem for a matrices from a linear transformations. The given condition is only given a transformation, we have to find out the matrices. In that problem, if a linear transformation which is defined as T of a comma b is equal to a comma a plus b, from T is a function transformation from V2 to V2. We find out the matrices linear representation of linear of a transformation T under a order basis. Here A equal to get that base 1 comma 1 and 0 comma 1 and B is the standard basis 1 comma 0 and 0 comma 1. Here the transformation is function from V2 to V2. So the dimension of the value is V2 is 2. So we take the transformation T of 1 comma 1. Here put the value for using T of a comma b, a equal to 1 and b equal to 1. Substitute T of a comma b, we get that a first value is a 1, second value is a value 1, b is value 1 again 1, here 1 plus 1 equal to 2, we get that T of 1 comma 1 equal to 1 comma 2. Again we using the standard basis 1 into E of 1. E of 1 is nothing but 1 comma 0, 2 equal to E of 2 into 2 equal to E of 2 is nothing but 0 comma 1. We have to multiply this 1 comma 1. 1 comma 1 plus 1 comma 0 equal to 0, therefore 1 into E1. Second value is 2 into 0 comma 1, that is equal to 2 E2. Next we apply that again, next basis T of 0 comma 1, put A equal to 0 in the given transformation and B equal to 1. The first value is A, we get that A equal to here 0, 0 comma A plus B, A equal to 0 and B equal to 1, therefore 0 plus 1 we get the 0 comma 1. Again using the standard basis 0 comma 1, the first value is multiplied by 0 into 1 comma 0, the second value is 1 into 0 comma 1. So here the identity value is 0 into E1 plus 1 into E2. The matrices of linear transformation T is a function from V2 to V2 related to the ordered basis of A and B is given that here the first value is 1 into E1, we get that 1, and in the row wise 2 into E2 is get that value is 2. So write it in that row wise 1 comma 2. The second value is 0 comma 1 can be written as 0 E1 plus 1 E2, you can write it as 0 comma 1. Is given that a linear transformation T of A comma B is equal to A comma A plus B. We have to find out the solution for by using this linear transformation we get that a matrices. Next we see the next problem. We in a linear transformation which is defined as T of A comma B, that is a linear transformation of A comma B is equal to A minus B into 3A plus B into comma 2A. From that transform here the transformation from V2 to V3. V2 is nothing but 2 basis element, number of element is 2, V3 is 3 elements. To find out the matrix representation of linear of a transformation T under his ordered basis A equal to 1 comma 0, standard basis 0 1 comma 0, 0 comma 1, here the vector B equal to 1 comma 0 comma 0, 0 1 0, 0 0 1. First we have to find out the value for 1 comma 0, that apply the transformation T of A comma B is T of A comma B, here A is equal to 1 and B equal to 0. Substitute this value in the given transformation A minus B, therefore 1 minus 0. Here the given transformation is 3A plus B, put the value for A 3 into 1 plus B equal to 0 and 2A A equal to 1. So we get that value is 1 3 2. Again we have to use the standard basis 1 into the standard basis of value is 1 0 0, 3 into standard basis 0 1 0, 2 into 0 comma 0 comma 1. So multiply these values, we get that 1 into E1, next value is 3 into E2, next value is 2 into E3. Again we apply the transformation for the basis T of 0 comma 1, here A equal to 0, B equal to 1. So substitute this value in that transformation, we get that A is 0, 0 minus 1, next value is 3A plus B, here A equal to 0, B value is 1, next value is 2A, A equal to 0. So substitute that 0 minus 1, we get that minus 1, 3 into 0, 0 plus 1, we get that 1, 2 into 0, again we get that 0. By this basis, we using that the standard basis minus 1 into 1 comma 0 comma 0, we get that minus 1 E1, next value is 1, 1 plus 0 comma 1 comma 0, we get that E2, next is 0 comma 0 comma 1, that is equal to 0 into E1. By using these values, we write it as a matrices 1 3 2. Here the value is 1 E1, 3 E2, 2 E2. Here also we write it as in a column wise 1 3 2. The next value is minus 1 E1 plus E2 plus 0 E3. We can write it as in the column second column minus 1 1 0. This is a matrix representation for a given linear transformation. Next we see that the third problem for example for matrices from a linear transformation. Here T of A comma B comma C is equal to 3A comma A minus B 2A plus B plus C. Here the transformation is T is a function from V3 to V3. By using the standard basis Standard basis, you know that 1 comma 0 comma 0, 0 comma 1 comma 0, 0 comma 0 comma 1. First we apply that basis t of 1 comma 0 comma 0. Here a equal to 1, b equal to c and c equal to 0. Substitute this value in that given transformation. Therefore, we get that, put value in a 3 of 1, a equal to 1, b equal to 0. Therefore, 1 minus 0. 2 of a equal, here a equal to 1, b equal to 0, c equal to 0, therefore 2 into 1, therefore we get that value is 3 of 1 comma 2. By using the same standard basis, 3 of 1 comma 0 comma 0 plus 1 comma 1 into 0 comma 1 comma 0 plus 2 into 0 comma 0 comma 1, we get that value is 3e1 plus e2 plus 2e3. Next we take the second value standard basis t of 0 comma 1 comma 0. Here we use that a equal to 0, b equal to 1 and c equal to 0 in that given transformation. Substitute that given transformation, the first value a is 0, therefore 3 of 0 equal to 0. The second value is a minus b, here a is 0, b minus 1. Therefore, we get that minus 1. The third value is 2 of 0 plus b, 2 of 0 plus b value is 1 and c value is 0. Therefore, we get that 0 comma minus 1 comma 1. By using this, we multiply by the identity values 1, 0 into 1 comma 0 comma 0 minus 1 into 0 comma 1 comma 0 plus 1 into 0 comma 0 comma 1. Therefore, we get that minus e2 plus e3. Again, we use the third identity 0 comma 0 comma 1. Substitute here a equal to 0, b equal to 0, c equal to 1. Substitute that given linear transformation. Therefore, we get that 0 comma 0 comma 1. Here 0 of the standard basis 1 comma 0 comma 0 plus 0 into 0 comma 1 comma 0 plus 1 into 0 comma 0 comma 1. If the first two value is 0, the only value is E3. Then the matrices of linear transformation, T is a function from T3, V3 to V3 is related to the standard basis. Here the first value is 3, 1, 2, you write it in row wise, 3, 1, 2. The second value is E1 is 0, E2 is minus 1, E3 value is 1. So substitute the value is 0, minus 1, 1. The third value is 0, 0, 1. This is a linear transformation. I already see the first problem is the transformation is transformed to V2 to V2. Therefore, we get the 2 cross 3 matrices. The second problem is the transformation V2 to V3. Therefore, we get that 2 cross 3 matrices. The third problem is V3 to V3, we get the 3 cross 3 matrices. Here these three problems are only given for the linear transformation. We have to find out that matrices by using that transformation. Next we see that the matrices from the linear transformation. Find the linear transformation. T is a function from V3 to V3 determined by that matrices. Here the matrices is 1, 2, 1, 0, 1, 1, minus 1, 3, 4. This is 3 cross 3 matrices with respect to the standard basis E1, E2, E3. In that problem, is a given condition is only that matrices to find out that linear transformations. So, we know that the standard basis T of 1 comma 0 comma 0 that can be written as E1 at the given basis, row wise value is 1, 2, 1. This can be written as E1 plus 2 E2 plus E3. This is equivalent to the first row of the given matrices 1, 2, 1. Next value is T of 0 comma 1 comma 0. 0 comma 1 comma 0 is equivalent to 0 into E1 plus E2 plus E3. Therefore, we get the second row of the value is 0, 1, 1. The third value is 0, 0, 1, that is equal to minus E1 plus 3 E2 plus 4 E3, that is equal to minus 1, 3, 4. Here you find out the value for standard basis 1, 0, 1, T of 1 comma 0 comma 0, T of 0 comma 1 comma 0. The third value is T of 0 comma 0 comma 1. By using this, now consider the value of, now taking that the vectors basis vectors A, B, C, this can be written as E1, here A1, A into 1 comma 0 comma 0 plus B into 0 comma 1 comma 0 plus C into 0 comma 0 comma 1, that is equal to A E1 is a identity matrix is E1, second is E2 and also E3. Applying that transformation, T of A, B, C can be written as taking A outside, A into T of E1, B into T of E2 plus C into T of E3. Already find out the value of T of E1, T of E1 equal to 1, 2, 1. So, substitute here the value here 1 comma 2 comma 1. Next T of E2 equal to 0 comma 1 comma 1. Here also substitute the value of B into 0 comma 1 comma 1. Here the T3 value is minus 1, 3, 4. Here also substitute the value of C into minus 1 comma 3 comma 4. Just multiply the value. Here A is value is A into 1. Here the first value B into 0 is 0 and C value is minus 1. So, minus C. Therefore, we get that the first value is A minus C. So, the second one is 2A B into 1 and C into 3. Therefore, we get that 2A plus B plus 3C. The third one is 3A into 1. Therefore, A. B into 1 we get that B. Therefore, A plus B. The last one is 3 into 4. Therefore, we get that 4C. T of A, B, C equal to A minus C, 2A plus B plus 3C, A plus B plus 4C. This is the required linear transformation. In this problem, only given that matrices, you have to find out that the transformation. For this matrices, this is the final required transformation. T of A, B, C equal to A minus C, 2A plus B plus 3C, A plus B plus 4C. Next we see that another example for a matrices from a linear transformation. Find a linear transformation from T is a function from V3 to V3 determined by the matrices ABC, BCA, CAB with the standard bases. Here the standard basis is T of 1 comma 0 comma 0, that is equal to A E1 plus B, given the row value is A E1, B E2 plus C E3 equal to ABC. The second value is T of 0 comma 1 comma 0 is B E1, the second row is B E1 plus C E2 plus A E3, that is equal to BCA. The third value is T of 1 comma 0 comma 0 comma 1 is equal to C E1 plus A E2 plus B E3, that is equal to CAB. We first find the value of T of 100, T of 010, next value is T of 001. Next we take that x, y, z, already given that problem is only given that A, B, C, now taken that the value of x, y, z, here x into the transformation 100 plus y into 010 plus z into 001. Multiply that, therefore, we get that x E1 plus y E2 plus z E3. Applying the transformation on both sides, therefore, T of x, y, z is equal to T of x E1 plus y E2 plus z E3. Taking x outside, therefore, we get the x into T of E1 plus y into T of E2 plus z into T of E3. Already find out the value for T of E1 is equivalent to ABC. Substitute the value here. X into ABC, next T of V2 is the value is BCA, substitute the value here, Y into BCA, and T of V3 value is CAB, substitute the value is CAB, just to multiply and order the values. Here the first value is AX, in here the value is YB, AX plus BY plus CZ, the next value is BX plus CY plus AZ, the third value is CX multiplied by C into X, A into Y, next B into Z, therefore, we get that CX plus AY plus BZ. Here this is a required linear transformation. Now see that two types of problem, given condition, the first type one is given that the linear transformation, you have to find out the matrices. The fourth and the fifth problem is given condition only the matrices, we find out the linear transformation for the required matrices. Thanks for watching this video. I hope that it is very useful for you in the matrices of linear transformation in linear algebra. Thank you.